Yeah, let's go through that.
Hello, everyone. Welcome to today's webinar, Introduction to SingleStore Pipelines. My name is Diogo, and I'll be your moderator today. Before we begin, just a few logistical reminders. Today's discussion is being recorded, and you are currently in a listen-only mode. You may submit questions throughout the session using the Q&A function in your Zoom webinar console. After today's webinar, you will receive an email with the recording. You may submit questions throughout the session. And allow me to introduce our speakers today. We have Manish Kumar, he's the Principal Product Manager here at SingleStore, and Vijay Raja, the Senior Director of Product Marketing. Welcome, Vijay and Manish. Vijay, you now have the floor.
Awesome. Thank you, Diego. Good morning, good afternoon, good evening, everyone. Thank you for joining us today. As Diego mentioned, my name is Vijay Raja. I'm the Senior Director of Product Marketing here at SingleStore. And it's great to be here today with Manish to talk about introduction to SingleStore pipelines and really to do some show and tell around how to easily ingest data into SingleStore. Okay, so here is what we'll have in the agenda today. We'll keep it fairly interactive. We'll keep it fairly open and flexible. But what we'll do is I'll kick it off with a quick introduction into SingleStore DB and talk about some of the key capabilities of the platform. We'll then go through an overview of SingleStore pipeline specifically, how it works, and then how it looks under the hood. I think that's going to be helpful for a lot of the audience here. Manish will also walk us through a couple of demos today around ingestion from Kafka and ingestion also from CDC from MongoDB as well. And we'll also talk about some real-life customer case studies and customer stories as well, right? So yeah, we have a lot to cover today, and hopefully we'll have some time towards the end for some Q&A as well. So again, as we go through this, if you have questions, as Diego mentioned, feel free to put it in the Q&A chat window, and we'll try and cover that towards the end. Okay. With that, let's jump in. But before I jump into the details around pipelines, I want to spend a little bit of time going over the basics of SingleStore and provide some more context, especially for folks who are not that familiar with SingleStore. Okay. So what is SingleStore? SingleStore, the way we're talking about SingleStore now is SingleStore is a single unified database to transact, analyze, and contextualize on data in real time. Now that's a lot of words. What do we mean by that? Okay. In plain English, it's a distributed relational database that can do transactions, OLTP workloads, analytics, which is OLAP workloads, together with vector capabilities in a single engine without any data movement. So really, it becomes really the single store for your applications. Okay. So you might be wondering, okay, that's all good. How do you guys do this? Okay. So when it comes to transactions, SingleStore has an in-memory row store that can do extremely fast writes and fast record lookups. And we are built as a distributed SQL database that is horizontally scalable, right? So that means as your data grows or as your business needs grow, you can scale horizontally by adding more nodes. Now, and then that you can then use that to power mission critical applications, right? Now, when it comes to analytics, we also have a column store, or what we call the universal storage, which kind of brings together the best of row store, column store together. But that is used to drive high performance analytical queries or run large scale aggregate functions. And speed is typically really in our DNA, right? So when we do queries, we deliver millisecond latencies. And now with the fact that with the column store, you also get 80 to 90% compression ratios to help keep your costs down. Okay. And this is what is really helping you power those real-time analytics aspect as well. Now, when it comes to contextualizing, this is really all the AI or vector capabilities that we have done a number of workshops and webinars on this one, but this is really the Gen AI capabilities, right? And the beauty of this is SingleStore has had vector capabilities since 2017, way before the Gen AI revolution. And we already have customers using it today to power things like semantic search, interactive chatbots, image recognition, facial recognition, and so on and so forth. And we also have notebooks which allow you to run Python and SQL code on top of the database, which we'll look into later today as well. Okay. But the question is, okay, why does all of this matter? I just want to give you like, how we, what are the key capabilities? But the reason it matters is now that since you can now transact, analyze, contextualize in data in real time, you can now power these mission critical applications, your data customer facing applications that and serve analytics through the application, right? And you can do this at 10 to 100x better performance and 1/3 the cost. You don't have to have tied together 7 different engines to power your applications or power your applications with analytics, right? You don't have to move data around. You can eliminate ETL. So now the concept of zero ETL is really gaining traction, and we are built for zero ETL, right? So eliminate ETL, eliminate unnecessary data movement, and really drive up the performance by 10 to 100x. And we'll go through some customer stories to give you a little more context on how this really plays out. Okay. Okay, so we talked about what is SingleStore a little bit, but okay, so who runs on SingleStore today? So today we power data intensive applications for some of the leading brands across the world, including 5 of the top 10 banks here in the US. We power applications for industry leaders such as Hulu, Siemens, Akamai, GE, Comcast, Dell, Cigna, P&G. I could go on and on, but you get the idea. We power the Fortune 500 and the Fortune 1000 organizations, but there is also a big segment of our customer base that are the tech disruptors, right? The SaaS disruptors. So you look like the fintech, the ad tech, the martech, the cybersecurity tech companies, the new SaaS techs of the world. They have a lot less baggage, legacy baggage to deal with. So they want to power their platforms with the modern database that's built for speed and scale, right? So we have a number of those customers who we have about 100 and 150 SaaS companies who are using SingleStore to power their applications. And we'll talk a little bit about some of the case studies as well. But let's pivot a little bit to today's topic, which is pipelines and data ingestion. But before I go into the details, let's put this in a context, right? Let's think about why this matters at the end of the day. So if you think about a data warehouse or an analytical database, people typically tend to focus on the query performance. Hey, what about my query latencies? I have a complex set of analytical queries, and how fast can it execute on those queries, right? That's the primary focus. That's what even the TPC benchmarks, TPCH benchmarks focus on as well, is how fast did the query execute once the data is already in the data warehouse or in the analytical database, right? But the thing is, that's only part of the story. That's only a small part of the story, I would say. A big part of the story, or a big part of the challenge, is just getting data into the data warehouse or into the analytical database, right? Typically what happens, you have data sources, multiple different data types, data sources, and it might land in one or multiple different operational databases or a data lake. Then it has to go through a complex ETL processing and batch windows, which we all love to hate, right? ETL batch windows, anywhere from, it could take 1 hour, 3 hours, 6 hours, 12 hours, 24 hours, depending on the downstream dependencies, right? So yeah, you are intimately tied to those batch windows, and it's complicated and it takes time. So the question we need to ask really is, how long does it take once a piece of data is generated to when it really shows up on your dashboard or on your application, right? So query speeds is important, but this overall time to insight is even more important, and customers are starting to talk about this even more today. For Hulu, the overall time to insight was 17 hours prior. We brought it down to a few minutes or a few seconds, right? 17 hours to a few seconds, end to end. And that's what matters. So query latencies is important. Query latencies is important, and that's a big part of the equation. But what you need to really focus on is the overall time to insights. And this is why high-speed ingestion and transformation capabilities are critical for today's applications and for today's use cases. Okay. So with that, let's dive in a little bit more. So what are some of the key capabilities that SingleStore provides, or what our customers really leverage when it comes to powering these kind of applications? So number one is this real-time ingestion, right? What we're here to talk about today. So using SingleStore pipelines, you can do parallel high throughput streaming ingestion up to millions of events per second from distributed data sources such as Kafka, S3, Azure Blobs, HDFS, and a lot more, which Manish is going to double click on. And the thing is, all it takes is 2 lines of SQL. Just 2 lines of SQL, and you can ingest millions of events per second of streaming data and have it immediately available for query. It doesn't have to go through transformations. It doesn't have to go through a whole lot of waiting period before you can query that data, right? So data can be queried as it lands, and it's just 2 lines of SQL. Some of our customers are ingesting over 12 million transactions per second. Hulu is ingesting well over 2 billion rows per hour and analyzing data as it lands. Okay, so this is obviously a critical aspect, and we'll talk a lot more about pipelines and real-time ingestion today. Okay, but remember, if you go back to that picture I mentioned earlier, there is real-time ingestion, but then you also talk about low latency queries, right, which is equally important. Now, when it comes to SingleStore, when we do queries, we deliver sub-second latencies, usually millisecond response times. For many customers, our SLAs is 20 milliseconds or less. And for some of the customer-facing applications, it's 10 millisecond application response times, even with high concurrencies, right? So this combination of streaming fast ingestion together with low latency queries on data as it lands is a powerful combination. It's a powerful set of capabilities to have to power a lot of the use cases that we are starting to see today, especially when you have customer-facing applications or user-facing applications that needs to serve analytics on those applications. Okay. Now, added to this is the fact that I kind of mentioned about this before, which is really these hybrid transactional analytical processing, or what we call HTAP, right? This is with SingleStore, you can just have a single engine for both transactions and analytics. This becomes this kind of drastically simplifies the data landscape for a lot of the organizations, right? You just now need a single engine to do transactions analytics and deliver high performance analytics for your applications. Again, no more complex ETL, no more data movement, no need to replicate data. By the way, if you already have a whole set of engines and you want to keep those, that's totally fine, right? We can still speed up your ETL by at least 10x. But if you're starting fresh, or if you don't have a lot of legacy baggage, like a lot of the SaaS companies and other innovators, you know what? You don't have to tie together 7 different engines to power your applications. Okay, so that becomes very powerful. More importantly, we are also MySQL wire protocol compatible, which means anything that works with MySQL, which is the bulk of the systems out there, or the BI tools out there, or your existing systems out there, if it's MySQL wire protocol compatible, it's automatically compatible with SingleStore, which means it's very easy to migrate applications to SingleStore, very easy to integrate with other applications. Okay. More importantly, we also launched a MongoDB wire protocol, which is called SingleStore Kai, that we launched earlier this year, which means, again, the same MongoDB queries, you can now run 1000x faster analytics by pointing those MongoDB queries, same MongoDB queries, to SingleStore. Okay. And again, it makes migration from MongoDB even more easier and seamless. Okay. So again, so this combination of real-time ingestion, fast analytics, and the fact that you can do transactions analytics in a single engine makes it really, really compelling, and makes you achieve things like, 0 ETL or 10x faster ETL, or 10 to 100x faster applications. We'll talk about a few case studies as well later today. Okay, so you might be wondering, okay, how do you guys do this? Like, how does it look under the hood, right? So I want to spend a few minutes talking about the under the hood architecture before we jump a little deeper into the pipelines. Okay, so as I mentioned, under the hood, we have data pipelines. This is our mechanism to ingest data ultra fast, millions of events per second into SingleStore. But then what is really unique is also our unique 3-tiered architecture, right? So we have a 3-tiered architecture which splits data between in-memory, on-disk, and the cloud object store. Okay, in-memory, on-disk, and the cloud object store to maximize the performance. Now, as you ingest data, all data is first written in memory. And what that does is it makes it instantly available for querying. So you don't have to you can actually query the data as it lands because it's landing in memory. Data is then committed immediately to the disk, and it could be a SSD or a NVMe, depending on what you prefer. And that's really the tier 2 storage. that makes it ACID compliant as well. Okay. And I mentioned this persistent cache, and that's the column store that gives you the advantage of fast analytics, but also gives you the compression ratios of up to 85 to 90% to help lower your TCO. Now, if that wasn't enough, we also, obviously you have the tier 3, which is the cloud object store or your object store, right? So data is automatically hydrated into the object store asynchronously, essentially offering unlimited storage capacity, or what we call bottomless storage, right? So you can have, we have customers have petabytes, 30 petabytes, 40 petabytes of data, and still be able to drive fast queries, fast ingestion, and fast analytics. Okay. But the beauty of this is all of this with separation of storage and compute, right? So which means you can obviously scale compute independent of storage, which is how that 30 petabytes of data can still work and still drive compelling latencies and compelling response times for a lot of our customers. And then, as I mentioned, the way to think about the three layers would be, hey, an easier way to think about that would be like all of the hot data stays in memory, warm data could be in the disk, and then the cooler data could be in object data storage. Okay. And all of this coordination happens under the covers without any manual intervention. That's the beauty of the platform, right? And that's what enables us to deliver ultra fast performance at scale while optimizing for cost as well. And now, I mentioned about the distributed aspect of the platform. That's what you see on the right side is like, hey, it's based on aggregators and leaf nodes. So if you have more data, all you need to do is add more nodes and scale out horizontally as your data or as your business needs grow. Okay. So I hope that gives a little bit more, sense of what the architecture looks like and why we are able to drive those 110 to 100x faster performance uniquely because of the 3-tiered architecture. Now, we also introduced SingleStore Radian as a data integration service recently. Now, this is what this essentially does is it brings together all of our capabilities, including it's underpinned by SingleStore pipelines, which we'll talk about, which does the ultra fast ingestion. But then we also have new innovations here around CDC in from MongoDB, CDC in from MySQL, CDC out of SingleStore, right? And then we also have a few others in the pipeline that's coming up, including CDC in from Postgres and also from Iceberg, which all of this, Manish is going to talk a little bit more about the other components, right? But what this helps is it makes it seamless and easy for you to bring data in from any of your regular sources, or just makes it easy for you to integrate data from all of these multitude of data sources. Okay. So we'll double click a little bit on the pipelines today, and then Manish will cover a little bit more on that. But before we go there, why does all of this matter? Like, how does this work in the real world? Okay. So I want to give you a little bit of a context and a real life customer story. So this is one of the largest retailers in the US, Fortune 100 company with over 100 billion in revenues and about 2,500 plus stores all across the US. Okay. Their challenge, they're primarily, one of the key areas of problems for them was their inventory forecasting process. The inventory forecasting process was incredibly complex. It was time consuming. And it was also very fragile and error prone, or failure prone, I should say. The reason was that this inventory forecasting required a 1.5 billion row operation, 1.5 billion row operation. That took over 8 hours to perform. It took like 8 hours, right? And the inventory operation routinely failed, bringing down the entire store's inventory system. And so this was an ongoing aspect for them. And what happens is when an inventory operation fails, it might take anywhere from 5 to 6 hours for technicians to be alerted and somebody to be dispatched to be able to fix this, right? So imagine like 6 hours of downtime, and customer estimated that they lose approximately $5.5 million worth of labor just related to these failures, just on these failures. And that relates to about $1 billion in productivity loss for them, $1 billion. So it was $1 billion problem for them technically, right? And the challenge was, again, under the covers, they were using Azure SQL, they had Cosmos DB, they had Redis, They had a lot of data movement and complexity that they had to deal with. And so obviously this was a key problem for them. So they did an extensive POC to solve this problem, and they looked at a number of vendors and a number of solutions. So they did so I want to tell a story here. Like they did a POC with SingleStore, and this is how we got engaged with them. So they did a POC with SingleStore, and then one of the goals for them was, again, this was the agreed upon success metrics, was we need to ingest and process 1.2 billion row inventory job, right? Their current performance or previous performance was around 4 to 8 hours, between 6 to 8 hours typically. Now their goal was, hey, can we ingest 1.2 billion rows in under 30 minutes or less? That's a win for them. That was the desired performance. Okay. So this was our POC goal, was to hit 1.2 billion rows in 30 minutes or less. Guess what we did? SingleStore, we said, you know what, we'll up the ante. We almost 3x'd the number of rows. We said we can do 3.5 billion rows and did it under 7 minutes. Okay. 3.5 billion rows in under 7 minutes. So that's like a 1400% improvement over their desired performance, not even their current performance, over their desired performance. Same thing for another 820 million row update. 1 to 2 hours was the previous performance. They wanted it under 30 minutes. We did 830 million rows in under 10 minutes. Forget 30, right? So that's another 1200% improvement. So the reason I'm showing this was, this is a real life case study. This is what really happened. This just tells you the power of ultra fast ingestion and the fact that you can now ingest data and analyze data and power these kind of applications, including inventory forecasting applications, including supply chain applications, or any of these applications that you have out there, right? And what this meant was, for them, for the customer, this meant they will realize several $100 million in savings related to labor cost associated with all of these inventory job failures. And more importantly, the customer also estimated that this will be able to help them increase their balance on hand accuracy by at least 10%, which will help them generate additional $50 million in revenue. So again, huge impacts beyond, these are some operational numbers, but when you put that in business perspective, it means a big impact from a use case perspective and from a customer operational perspective. Okay. So with that, I think I kind of gave you some idea of introduction to SingleStore, what we do in pipelines at a high level, and then why this matters. But let's double click on pipelines. Let's dive a lot more deeper. So Manish, I'm going to now pass this over to you to dive a little bit more deeper into pipeline specifically.
Sure, Vijay, and thanks. It was a great introduction to what SingleStore is and how certainly ingestion and fast ingestion plays a key role in building real-time applications for customers. So with that, I wanted to go over some of the details around what is pipelines, how do we actually do these fast ingestion, and what is the secret sauce behind this, followed by a quick demo of some of the ingestion patterns that we see from customers. So would like to go through that. So just by way of introduction, I'm Manish. I'm one of the product managers who drives the ingestion area roadmap for SingleStore. And one of the key product that we offer here is SingleStore Pipelines. So what is SingleStore Pipeline? It's a streaming ingestion capability for SingleStore, which allows fast and parallel bulk loading with millions of events per second. And we will probably see that in the demo itself. Customers can optionally do transformation of their data, because that's data comes in different shapes and forms. Customers want to transform their data to meet their business needs. And SingleStore Pipeline does provide that capability through very simple SQL interface. We provide transactional consistency and exactly one semantics. We do not want to cause data inconsistencies, and that's certainly something that Pipelines takes care of. We support 4 major formats, which is JSON, Avro, Parquet, and CSV for ingestion. But when we look at the sources from where we can ingest, we can see we can do ingestion from HDFS file systems, Google Cloud Storage, Azure Blob, Amazon S3. These are standard sources. We support real-time streaming services like Kafka today. But more importantly, we recently introduced the sources like which are more of databases as a source, which includes Mongo and MySQL, which is in preview, and we plan to GA it very soon. And all these sources can ingest data in real time as it happens on the source side into SingleStore with all the capabilities that I talked about. Can we go to the next slide, Vijay? Okay, so let's look into how essentially pipeline delivers this and what's the workflow for achieving this functionality. So as you can see from left to right, we have all these sources that you see where data can be present for customer, and based on their business needs, they would want to move it into SingleStore. The 4 file formats that we currently support, Avro, JSON, Parquet, and CSV, are basically pulled in from the source system. As I mentioned, you can do optional transformation, which can be either done through stored procedures today, or you can write your own custom transform on the self-managed deployment for SingleStore. These are then inserted inside SingleStore, and this is where the magic happens. These insertions are actually done in parallel so that we can get the parallelized benefit of SingleStore DB, and these can be parallelized to the extent of the number of partitions that you have on your database. So with some of the Kafka ingestion that I will show in the demo, we can go as high as millions and millions of records being ingested per second, just because we can parallelize it over the number of partitions that the database supports. In all this process, these are delivered through simple SQL interfaces, and I think it's literally 3 SQL commands that you need to create and run the pipeline. And we provide extensive debug capabilities that can help you either program your pipeline or be able to debug and scale your pipeline based on your application needs. Can we go to the next slide, Vijay? Okay, so wanted to specifically dive into 2 of the pipeline options that I would want to demo as well. So if you look at a Kafka pipeline, which is a very common pattern when people want to build real-time application, and these Kafka topics can store any sort of record. It could be a database transaction, it could be a metrics, it could be an IoT data, you name it, Kafka supports that. However, when it comes to ingestion inside SingleStore, we can literally parallelize these Kafka topics into the number of partitions that your database supports. Of course, there is some metadata being used for coordinating the effort, but from a Kafka to a SingleStore interaction, the parallelization literally boils down to the number of partitions that you can have on your database side. And with some of the customers, they have been able to achieve massive scales just because they designed their database correctly, and that helped them go get that 1400% improvement that Vijay talked about in the previous slide. Can I go to the next one? Okay. The other capability which I wanted to dive deeper into is how do we run the transform? Now, transformation is a very important capability that most of the customers really want to use, because it helps them align their data to their business needs and be able to get the benefit out of it. These transformation are achieved through simple SQL interfaces, or in case of self-managed, you can literally use your own custom transform code in any language. And these transforms are executed on incoming data before they are loaded into SingleStore DB. Now, because these are done even via SQL interfaces, these are exceptionally fast as it can run close to the engine itself and be able to get the real power of SingleStore itself. Now, in the next slide, Vijay, can you go to the next slide?
Mm-hmm.
Yeah. Here's a simple example of how you can literally transform your data using a simple stored procedure, where as I'm getting my tweet data, I am trying to either clean up my data or be able to do some sort of an aggregation as a part of the transformation process. And that is where most of the customers really use their data as they bring in data from either an IoT device, or whether it's a database where they want to move the data into SingleStore, and they use Kafka or something to transform their data into SingleStore as they write into SingleStore, and then make it ready for SingleStore's consumption. Can we go to the next one? Okay. Optionally, the other demo that I wanted to cover as a part of this webinar is around the new capabilities around the real-time CDC from Mongo. Now, Mongo stores their data in the JSON format, while SingleStore traditionally supported only the object store and data stored in these the 4 file formats, average, JSON, Parquet, and CSV. However, with this capability, what we have introduced is a way for SingleStore to directly interact with MongoDB clusters to pull data from the MongoDB clusters inside SingleStore. We can additionally run some transformation. So if you really want to, let's say, flatten your JSON object into a SQL interface, you can really do that with a simple transformation that you can write on your incoming data. You can optionally, you can also bring in your data as is from your Mongo clusters and make use of the SingleStore Kai, which provides an easy interface to talk to your and not change your Mongo applications while you are interacting with data stored in SingleStore DB. These ingestion pipelines from MongoDB takes care of both the historical data, which is what we call a snapshot, as well as changing data, which is the CDC part of it. And we take care of all this without use of any third-party tool, which traditionally costs a lot. So it's a cost saving as well as a speed solution for customers to move their data from their MongoDB clusters, no matter where they run, into SingleStore DB with just a simple SQL scripts that I'll show in the demo itself.
Yeah, that's a great point, Manish, because again, obviously, if you think about it, this is just one license. It's one standard license where you can get SingleStore, all of the stuff that we talked about, plus SingleStore Kai, which is really this MongoDB API that helps you run 1000x faster analytics, plus the CDC replicate tool for MongoDB. All of that comes as part of the standard license, right? So it's incredibly, and this is how like customers are able to achieve 1/3 their cost compared to some of the other legacy platforms that they are on. So great point, Manish. But I think let's see some demo. I think we should see the demo in action now, right?
For sure, for sure. So like I'll take over the screen sharing now.
Let me just stop sharing. Yep.
Yeah, just a second. Okay. Okay. Can you see my screen, Vijay?
Yep.
Okay. So here is our SingleStore portal. Now, now people can just log into SingleStore through portal.singlestore.com. This is our portal, similar to any of the cloud services portal. People can create their own account. In this case, I have already logged into my account. When you try to sign up for this account, you get free credits of $600 worth of credit, which can be really used for testing out SingleStore, its capabilities, and this is good enough for you to last for a month, depending upon the size of the cluster that you choose. But it's a good starting point for customers as they interact with SingleStore. Within this portal, I just want to take a minute to describe what we are seeing here. We have these workspaces, which are basically all the compute and the databases that is really used to query your data or store your data. And we have some of the developer tools like the notebooks that we GA'd yesterday. We also have our own SQL editor and Kai shell, which really helps people who are familiar with the Mongo interfaces and they just want to use that with SingleStore data. As well as we have some monitoring capabilities that can help you see the value of what you can really get, whether it's looking at your historical queries, your infrastructure performance, or whether it's your pipeline performance. You can really take benefit of it. I would want to go over the two demos that I talked about. The first one being ingestion from Kafka, followed by the one with MongoDB CDC, with the Mongo CDC pipeline. So let's switch into this. So as you can see, I have two workspaces that I have created here. One of them is what I'm going to use for my Kafka ingestion. So just to show what my Kafka data looks like, here is a Kafka that I'm running on EC2 instances. This is just a way to visualize all these things. This is one of the topics that I have, which has a lot of data where I can view the messages like these are the messages that I have. I roughly have like 4 billion records here, which really shows like at what scale I'll be operating and at what speed I'll be ingesting into SingleStore. In my workspace, as I can see, it's an S8 cluster, which comes up with its own size, and I can see all the workspace details here. This is basically created for the purpose of this demo. Now, going into how we want to do the ingestion, right? So the architecture of the demo is pretty straightforward. We have a Kafka topic, which is getting real-time data into Kafka, and we are ingesting that into SingleStore without any other tool in between, but with just simple SQL scripts that helps you move the data into SingleStore. Now let's quickly go through this demo, and I'll go through each of these steps that I'm executing here. So I'll just create the database, which is for 64 partitions. Typically, it's really tied to what size of cluster you provision. Because I have an S8, I can really provision 64 partitions that I need for my data. This is just the table creation, which talks about the data, the table in which I'll be getting my data in. So I'll just execute this, and this will create my table. So this is the first command that is really creating the pipeline. As you can see, it's a simple SQL script, which is create pipeline, your pipeline name, the Kafka topic, which I'm using to ingest the data, what's the batch interval, and these are configurable parameters that people can have on their pipeline creation. There is a mapping that I need to provide here right now, and we are trying to simplify this experience even further to make it like just even a simpler SQL script. But the idea is that we just create this pipeline which maps to a specific table, and the data on the ingesting data is landing into SingleStore. So let's run this command, which essentially creates the pipeline. Okay, so now my pipeline is up and running, and you can clearly see that show pipeline. You can see that your pipeline is up and running. It's currently stopped because I haven't started it. So we're just changing this max partition, which is one of the configuration on pipeline, to 64 to be able to make use of the 64 partitions that we have on the database. Before we get started, we can quickly do a sanity check to see everything is working fine. So it's just a test pipeline command, which does pull 10 first-10 rows to show that your data is there and it's being correctly fetched. So let's give it a second. Okay, you can clearly see that my data from my Kafka topic is being ingested. Currently, nothing is being ingested. This is just nothing has been ingested. It's still empty. So the count star from my table should report empty. So now I will just start the pipeline, and that's the simple command you need to run to basically start ingesting your pipeline. And as you can see, now the data will start flowing in, and very soon we can see that the data will start flowing in, so now you can see that these data is being replicated into SingleStore. And as you can see here, right, one thing to note is what is the number of rows being replicated per second. We can clearly see that roughly 3 million rows are being ingested per second. And that's the scale at which we are ingesting inside SingleStore. Of course, the number of rows on the Kafka is approximately 4 billion, so it will take some time. But certainly the ingestion rate is picking up, and it will standardize on some value, but we can clearly see that as and when more batches are being executed, the ingestion rate is upward of 3 million records per second. Now, this is via SQL editor. You can actually do the same thing via a simple notebook that I mentioned that we just GA'd yesterday. It has been in preview for quite some time, and people have been making good use of it. to be able to write their own custom scripts and just make use of the same Jupyter notebook feel inside SingleStore. And these are tightly integrated solutions. So here's a simple example which does the same thing. I'll not run the pipeline because the pipeline already exists, but it just shows that you can really orchestrate these pipelines for your business needs based on what you want to ingest and how quickly you want to ingest. So with that, I wanted to move to the second demo that is about how you can ingest data into SingleStore from your MongoDB clusters. So for the purpose of this demo, the setup, I just wanted to explain the setup here for you. It's a MongoDB Atlas cluster. I'm using one of the default collection that exists inside MongoDB. So this is my account. I have some MongoDB data. So I'll make use of this sample Airbnb, which has around roughly 5,500 documents. And I'll be ingesting that into SingleStore with the same interface that I just showed for Kafka, but just at a much faster speed. So let's jump into the demo. So let me just do some cleanup, and I'll just execute this command to create a database where I would want to ingest the data. So let's this be executed. Okay, so this should be done.
And as we're waiting, Manish, there's a couple of questions on if we can share the notebooks. I think we should be able to share both of these.
Yes.
Yeah, so Charles and a few others inquired, can these notebooks be shared? So yeah, we'll be sending out an email after this with the links.
And I'll talk about a new way for us to share more notebooks towards the end of it. So let's wait for that as well. So okay, so now the database is up and running. The database has been created, and this is basically the SQL command to connect to my MongoDB cluster. And all I'm doing is configuring my host, which essentially points to the primary and the shard nodes. What is the collection list I want to import inside SingleStore? Some SSL configuration and some credential part. So certainly I would change the credential post the webinar, but it's there. So let's create this link. And essentially what I'm doing is I'm just creating a link. Link is a way for establishing a connection to an endpoint, and we can use these links in our future future commands for running pipelines. So this is just running some extractor pools because as we run more pipelines, the extractor pools gets consumed, so we can just flush them out. So what is this command of schema inference is doing? So what this is doing is it helps infer the schema from the source collection inside SingleStore without doing any manual creation. So let us run this first. Or before this, let me just check what is the show tables. Let me just select the database name here. And let me see what's the table name. There isn't any table existing right now. So what this will do, it will read the source collection, which is the Airbnb _ asterisk. So basically every collection under the Airbnb, which is just one right now, but we can pick anyone which has some more databases, and we can just create this inferred schema out of it. So let's run this, and then let's see the show tables again. Sorry. Okay, so you can clearly see that we have created a new table which essentially maps to the same schema that exists on the source side, except there is a new variant, a new column that gets added on SingleStore side, which I'll show you as I ingest the data inside SingleStore. Now, similar to what we had done previously, all we need to do is, so if we look at the count star right now, it should be empty because we haven't started the pipeline. Let's start the pipeline and see what happens. We will clearly see that very soon this will start getting populated, and let's run this. So as more and more rows get ingested inside SingleStore, let's wait a second. Okay, just a second. Let me do this. Let's try. I think I ran it once before, so there could be some issues there, but we can quickly fix that. Okay. Let's see the show tables here. I can see that there is a movie table here, which I think should have the data replicated. So yeah, so it could be some issue of cleanup. So I removed data from a different collection here. So there's an mflix table. As I said, as I inferred the table, it just infers all the tables that are there in the mflix collection. So we could clearly see that all the tables that it had, which is comments, movies, session, theater, users, got ingested, got created. And once I started the pipeline, the data started flowing in, and pretty much all the data has now been replicated. So if we want to validate this, if I go to the movies collection, there would be roughly 4,000 something rows existing here as well. So it should just be ingested very soon. So I think it's still being ingested. Yeah, so from all the databases, we are constantly ingesting more and more data. And if I show you what exactly is ingested, I'm just selecting one of the table here, but pretty much all the table looks pretty much the same. So we have this ID column and the more column. And the more column is basically referring to the data that exists on the collection here. So if there is any data that exists in movies, that would be part of the more column here, while the ID refers to the ID field of the object ID field that the MongoDB clusters have. Once the data is in SingleStore, you can either run a regular JSON query, or you can use the SingleStore Kai Mongo to run your Mongo queries on top of this data, because this data is now readily available for your query. This clearly shows that we can, and this not only takes care of the initial load, but if there is a change that happens on the source side, that gets easily replicated onto SingleStore without any additional setup, because we are constantly listening to new changes happening on the source side and simply replicating that onto SingleStore. So once this is complete, or I can look at some other table which is already completed. So let's see if comments is already completed.
I think you missed C. Comments.
Oh, sorry. Yeah. Let's see how many rows documents are there in comments. Yeah, it's still being replicated, because some of these collections are pretty huge. So one thing I wanted to call out is with the Kai Mongo, with the CDC, Mongo CDC, based on the amount of based on the size of the cluster that we provision on SingleStore, people have seen upward of 1,000 or 100K documents being ingested per second, and that really talks about the scale and the speed at which SingleStore operate. People have been able to move terabytes of data in a few hours itself. So that really talks about the scale at which we have tested and made it available to customers. I would want to stop the demo and hand it over to Vijay for the remaining of the slides.
Yeah, awesome. Thank you, Manish. So hopefully that gives you guys a good idea of what's the art of the possible, right? So 3 million, Kafka ingestion, 3 million rows per second, and you saw the power of the Mongo CDC as well. What I want to do now, I know we have a number of questions that are coming, so I want to spend some time on questions. But before we go there, I want to just give you, I showed you an example earlier about a top 10 retailer, right? Who is, where we are using pipelines to ingest massive amounts of data in like short amount of time. I want to give you just two other quick examples. I probably spend only 2 minutes here because I want to get to a lot of the questions. I know we have more questions that we can answer, but But let me just quickly talk through this. So this is digital asset research. So I want to give another organization which is more on the SaaS side. They're a fintech. They provide clean crypto data to organizations like Bloomberg, Chainlink, FTSE Russell, so on and so forth, right? They have, they're close to like 200 million trades per day. They're originally with MySQL, it just couldn't scale. It couldn't handle the analytics. It couldn't handle the volumes itself. And it was constantly crashing and giving them issues. They moved to SingleStore about a year and a half ago. And again, look at some of these numbers. 1000x faster ingestion. Not 1000%. It's 1000 times faster. They're running 160 pipelines today, right? Ingesting data, real-time data, and then using that for analytics to power their application, to power the customer-facing application. And then again, 1000x faster analytics, 50% lower cost, right? This is what I was telling, and there are I can give you like 10 other stories like this. But the more important aspect is the scalability. With the previous platform, they were stuck to 20 to 30 million orders. That's all they could handle. Now they can go up to 140 million today, and room for growth as much as they want, still drive 1000x faster, fresher data, 50% lower TCO, right? Let me give you another example. LiveRamp. If you don't know LiveRamp, they're one of the leading ad tech firms. They were running legacy Hadoop infrastructure, right? Hadoop, and it grew increasingly complex, resulted in 12 data silos. They had 12 copies of data, right? And it took them 20-step process, 15+ hour process to get the data in. And this was leading to customer churn. They currently run 2,700 pipelines, 2,700 pipelines with SingleStore, ingesting large amounts of data. And guess what they're able to do? That 15-hour process is now down to less than 5 minutes. 15 hours to less than 5 minutes. So, and a 75% reduction in TCO. So that's the power of what this platform can do with this fast ingestion and low latency queries to power your applications. Again, it means a huge difference from a simplicity standpoint, but more importantly, from a cost perspective and from an application performance perspective, which ultimately translates to your ability to grow and your ability to retain your customers, right? So these are all impactful stories, and I'm happy to share more details on each of these stories, but wish I could dive deeper. So just a quick thing, what is coming? We are native Apache Iceberg integration is coming up, and then a CDC out for SingleStore is coming up as well. Manish, I don't know if you want to quickly touch upon a couple of these.
Sure, Vijay. So as we saw that we have these pipelines that are constructed from some of the sources that our customers use. However, the number of sources doesn't stop, but we want to have a more scalable solution, and that's why we are investing into building our own SDK that can be used by customers to create custom pipelines, whether it's from a streaming service like Pulsar, Kinesis, or it could be from some other sources as well, which we don't support natively. Secondly, I think a lot of customers have asked for it, and we think that supporting native ingestion and egress for Iceberg is something that we should support, and we are actively investing in it. And CDC out, as it's a standard feature that most of the databases have, and we are actively working on it. And we also intend to support it for building pipelines from SingleStore to another SingleStore, and that can help in building some HA kind of an architecture for customers in future.
Awesome, fantastic. So let's again, there are some resources to learn more, but I want to get to some questions. I think we have a lot more questions that we can answer right now, but let me start with the easy one. Pipelines. So I think I can take this one. SingleStore, the pipeline's available in SaaS DB only, or can it be run on premises as well? So Don, yeah, this is available. This is a native part of the core offering. So you can run this anywhere. You can run this on the cloud, any of the leading clouds, or you can run this on premises, right? Pipelines is an integral part of the solution, so you can run this basically anywhere. Will there be any examples from Amazon S3? Albert, so we have a number of examples where customers are ingesting directly from S3. It's one of the most common sources, apart from Kafka, that we see. Again, we can probably share like 15 different examples of customers doing high throughput ingestion. Yeah.
I'll just call out one more thing here. we recently introduced the concept of spaces, which are pre-created notebooks that are available for access in the gallery tab of our portal. So feel free to check it out. We have pre-created notebooks. Some of them are actually pipelines from S3, which you can directly use based on your application requirements. So feel free to go ahead and try it out.
Perfect. Thanks, Manish. So before I get to the other question, just a quick call out. What you see on the screen now is, again, based on what we talked about, we have an offer going on where you can try this on your data, or we can help try you this based on your data or based on CAN data in your environment, right? We'll pair you up with a solution architect who can help do a speed test for you if you're interested in learning more, or if you want to see how this performs in your environment, we can definitely do that. Feel free to sign up today, and you'll win free swag that you see there. And guess what? You'll also get $600 in free credit. So it's a great offer for anyone wanting to learn more or wanting to try out. Definitely do sign up for that offer. Okay. So Manish, I have a few questions here that I think I'm going to start posing. One is this: we have a few questions around Databricks for organizations that are currently on Databricks and Azure Data Factory. It seems like the in-memory database for fast data ingestion is the main differentiator that SingleStore is bringing. Can you touch upon that?
Sure. And I think I would love to point to a blog that we went out with yesterday, written by Adam, who is our co-founder, Eugene, an architect, and Dave Eiler, my manager. And we support, that's one of the key differentiation, where data for SingleStore, unlike data for Databricks and others systems, first hits into our in-memory storage, which I covered in one of the first few slides, and at that too at an ultra fast speed. And because it's already in memory, it's available for query, and that's the key requirement for building any real-time applications.
Yep.
You remove the process of fetching data from the cold or the warm storage, but you just have the data hot as soon as it lands, and that makes it a key differentiator against these other data products that you mentioned. Certainly, I would love you to dive deeper into that blog, and certainly we can follow it up as a part of the follow-up of the webinar, the link to that blog, which clearly outlines why SingleStore outshines Databricks, especially when it is the need for a real-time application building.
Awesome. So Manish, there is a few other questions here specifically around, can we support some of these? Is there any plans for, so Shiva asks, is there any plans for supporting ORC and Hive?
We do intend to support ORC, because if we look at the 4 file formats that we support, Parquet, Avro, JSON, CSV, ORC is one that we are missing. We plan to support that. For Hive, I would love to understand more about the use case. We currently do not have plans for it, but if you can shoot me a quick email, I can certainly look into the scenario and see if we can have an alternate solution that can unblock you for your Hive use case.
Okay. And just similar to that, is there a plan to support Spark Job / DataFrame as a pipeline source?
Not at the moment. We are not looking into that for anytime soon. Okay,
gotcha. Is there, by the way, if there's a specific question, Manish, that you see, there's a lot more that we can cover today, but if there's a specific one you think is important, feel free to jump in as well.
I would look at a couple of them that I think are important. One is the number of sources. People have a lot of sources where they have their data, and supporting each and every source might just be it's a very time-consuming process, and it takes time to build these things out. And that's why if we look at the investment that we are doing in building our own SDK, that gives the freedom to the customers to build their own custom pipelines from any source they want. And that is the power we want to give, and be able to engage with the developers who want to write custom pipelines from any source, any and every source that they want. And the other part I wanted to cover is, which I think I hear a lot, is people have various distribution of Kafka. Like Kafka is everywhere. People have self-managed Kafka. People have Confluent. People have Redpanda, AWS MSK, or other services. We integrate with Kafka, which removes the barrier of where the Kafka is running and how it is being managed. And that is where the power of SingleStore pipeline lies. We do not differentiate in different distributions. So we work as a SaaS offering, whether it's in the cloud or self-managed, we work with every Kafka distribution, no matter where we run. And more importantly, we cover the security pieces, which some of our customers have benefited from in all these pipelines that we set up from these Kafka sources.
Perfect, perfect. I know we are out of time, but let's cover this one last question, and then we'll probably wrap up for today. What happens if the in-memory cache failed with millions of records? How long will it take to recover?
When you say in-memory cache fail, is it more so SingleStore so that's irrespective of whether we're running pipeline or not.
Yeah.
SingleStore provides a high availability in its architecture itself. So for every write, we are able to replicate. It's a two-way it's a replication that we do for that data, so that every write it's persisted, and we are able to maintain the high availability of that data. That's part of our architecture, and I think there's a white paper that we can share to specific person who asked this question that clearly takes care of how the high availability architecture of SingleStore takes care of any sort of loss in any of the three layers that we mentioned in one of the first slides for this webinar.
Awesome. Awesome. Great. Thanks, Manish. So I think that's all, folks. That's all the time we have for today. If there are any other questions, feel free to send it our way. Send it to team@SingleStore, or you can reach out to either Manish or myself. My email ID is vraja@singlestore.com and mkumar@singlestore.com. So feel free to reach out to any of us. And if you need a further deep dive, happy to set up some time with any of you.
Yep.
But thank you everyone for attending. Appreciate all the questions and the interactions. We will be sharing the recording and also all the links that we mentioned throughout the webinar. We'll be sending the links to the slides, the recording, and also some of the other assets that we mentioned throughout the webinar. Thank you all for your time, and have a great rest of the day.
Thank you.
Okay.